In this video, I'll give you a quick overview of C++'s purpose, characteristics, and its status in the industry. C++ is pretty old. It was developed for industry needs and is not a theoretical or a research language. So commercial and practical software development considerations have always dictated where the language is heading. C++ inherits C directly, and it has influences from a number of dead languages. C++ itself has significantly influenced design of many later languages like Java or C#, and even though they are very different under the hood, they look almost exactly like C++ a lot of the time. C++ got standardized in 1998, and that standard lasted for 13 years. So there was quite a bit of stagnation. The C++11 standard was very significant, and it's what we call the beginning of modern C++. On one hand, if you examine what changed, it can seem like a bunch of small features, but the end result is a much cleaner language, and modern C++ programs can be structured in ways that were maybe possible but not practical before. And under the hood, the C++11 standard brings also very low-end changes to the concurrent programming model, a lot of stuff that is of interest in very high performance applications. The C++14 standard is only a small feature upgrade and not very relevant. Especially on this year's graphics course, Visual Studio 2013 supports most C++11 stuff, but not absolutely everything, and C++14 things are probably not going to be supported. The language has gone through a renaissance of sorts recently. Companies like Microsoft, Google, Apple, and Facebook have all invested heavily in C++ in recent times, and the language standardization process has accelerated so that updates are expected almost yearly now, and that's a huge difference when you look at the more than a decade that went between C++98 and C++11. So the philosophy of C++, according to its designer Bjarne Stroustrup, is that C++ is a lightweight abstraction language. So it allows low-level control when you need it, and there should be no need for a lower level language between C++ and assembler. And to accomplish that goal, C++ is designed so that you should never have to pay for features you don't want to use in performance. The default way of how you write things in C++ is usually plenty fast already. And C++ also allows writing code at a high level of abstraction, and curiously, it often comes with very little performance cost, sometimes no performance cost at all. And that is usually accomplished by compile time, code generation, and the template mechanism. One of the major upsides is backwards compatibility, and there are huge amounts of existing code in C++, C, and these languages have always interfaced well with pretty much all other languages, so access to libraries written in something else is usually also possible. So you can find C++ used everywhere when performance or power savings or responsiveness are needed, So C++ is used in operating systems, embedded devices, all heavy desktop applications. And there has been much talk of everything moving to the web and old languages becoming outdated, everything being coded in languages like JavaScript and running in the browser. But when you think about it, the browsers themselves are written with C++. So ultimately all of the web stuff is also. Graphics applications demand a lot of performance and low-level control, so C++ is a naturally good fit there. C++ is used on Aalto graphics courses because it is the standard in most of graphics research and the industry. And then to the bad and the ugly stuff. As part of the huge backwards compatibility and libraries of code, we also get all the bad stuff from C. So you can actually take most C programs and run them through a C++ compiler, and they are valid C++ code as is. And that means all of the unsafe, nasty stuff in C is also in C++. Writing clean, modern C++, using all the tools that the language gives you, you will mostly avoid the problems, but there are some things that are associated with very fundamental operations that you can't totally avoid, and you can easily accidentally trigger some of them. The whole kitchen sink design approach in C++ makes it a really hard language to learn. So a part of the language philosophy is that it allows the programmer to code in a style they find comfortable and in a style they find to be right for the project in question. So nothing is ever removed. Removing something from the language would break backwards compatibility, and there's just a lot of functionality. And there's, in a sense, there's 3 or 3.5 distinct programming languages wrapped together inside C++. There is the C programming language preprocessor, which is used mostly to help with building C++ programs. There is the template mechanism, which is a powerful programming language in their own right and can be used to do a lot of stuff at compile time. Then there is a new thing called constexpr, which is a special class of C++ structures that enable carrying out computations also at compile time. The C++ standard library is relatively small, very small if you are used to modern languages like Java or C#, so there is no built-in database connectivity. There has been no networking. A lot of stuff has just not been there, and we are now getting more with the latest and the next C++ standards. There are finally going to be some new standard libraries coming in, but still nowhere near as much as the recent languages. And this quote here: C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. You might think this quote is from someone who has an axe to grind with C++ and perhaps has a vested interest in promoting something else. But the source is Bjarne Stroustrup, the designer of C++. So the language is very much a power tool. You can do powerful things with it, but you have to watch out, and you really have to pick and choose what features you use and how you use them. And as I told you before, C++ tries to support a lot of programming styles. So you can write object-oriented code, but you don't have to. You can write really low-level code, but you don't have to. Not all programming styles are supported by C++. It doesn't really support functional style, for instance. Generic programming is worthy of note. It's one of C++'s biggest strengths. So the C++ generic programming mechanism, templates, is much stronger than its counterparts in Java or C#, but very complex also. So basically another programming language embedded inside C++. And how do we handle all of this complexity? We ignore it as much as possible. These videos, the assignments themselves, the assignment handouts are all designed to ease you into the part of C++ that you actually need, and deliberately omit the rest. So occasionally some of the assignment code provided to you could be written somewhat better if it was for production use, but that would require using more language features, which you would then have to learn. And this illustrates how it's supposed to be. So don't worry about all of the complexity. You don't even have to be able to read all of the assignment code and figure out what it does. Some sections you must be able to read, and then some sections you must be able to write. Some features of the language you have to be able to use. So not everything, and you will actually get by with using very little, but it's important that you have seen more features so that you know what they are doing when you encounter them while reading other parts of the code. That's it for this time. In the next video we go into Visual Studio and check out how apps are built and ran in practice.